Hello and welcome back to part 2 of the lecture. The network exploded, so we had to restart. We talked about the slope of the tangent line, and we said that we can find the slope of the tangent line, let's say at 3 for the given function, by doing this particular calculation. And then I asked you guys to give me the same function, give me the slope of the tangent line at what? At 5? And the answer was what? Answer was m tangent was negative 19. And then I said, how about at x equals negative 4? And the answer was 17. And then we can actually quickly answer these questions without calculating all of this mess up there, because some of you know certain things. Knowledge is power. But then, as I said, imagine this annoyance of constantly switching this x equals 3 to 5 to negative 4 to 7 to 103. Like, is there a more efficient way to do this? Because we're all lazy, right? To some extent. And the answer is yes. How about if I take my m tangent, which was the limit as h goes to 0 for f of xa plus h minus f of xa, which was the specific point, and transform that for every x. So we get m tangent is equal to the limit h goes to 0 of f of x plus h minus f of xa minus f of x, over h. What would this formula do? Well, we are observing that now we don't have xa, which is particular point, the point. We actually have just x. Could be any point. Any point. So you go and say, oh, that's cool, because I can solve this in terms of general x, and then no matter what x you come up with, x is 3 or 5 or negative 14, we can plug that in that general answer, and that will keep spitting out slopes. So now, the same problem, f of x negative 2x squared plus x plus 2, same as before, same as above. I'm going to find this general formula that figures out all slopes at once for this function. So now I'm going to say, so m tangents collectively is the limit h goes to 0, and now what do I have? I have negative 2x plus h squared plus x plus h plus 2. All of that stuff is just my f of x plus h. And then minus in parentheses, I have negative 2x squared plus x plus 2. Those are all pluses, right? Was it minus 2? Okay. I'm going to fix that. Because I remember there was a minus somewhere. So I'm just going to fix that minus over h. Now, don't forget to write these limits every single line until you actually use it up at the very end. A little bit of a line there. We have negative 2x squared minus 4xh minus 2h squared plus h plus x plus h minus 2 plus 4x squared minus x plus 2 over h. Why did I write 4x squared? It's supposed to be 2x squared. So now, minus 2x squared plus 2x squared, gone. Positive x, gone. Negative 2, positive 2, gone. And look what's left. Only terms with h. So that's going to be h, negative 4x minus 2, h, plus 1, divided by h. The plus 1 is kind of hidden. It's right this h that is not cancelled right there. You got to hunt for these things. So that's where the plus 1 comes from. And now h annihilates h over here. And the negative 2h goes to 0 in the limit. Well, actually, let's write one more time since it's the first problem. So now 2h will go to 0 because h goes to 0. And the answer is negative 4x plus 1. So this is how I was calculating things. I knew that. So when I asked you what happened with negative 4, for my head, negative 4 times negative 4 is 16 plus 1 is 17. I know the answer. If you are to say what happens at 25, 25 times negative 4, negative 100 plus 1, negative 99. I know all of the slopes for this particular function because I know this. But then you go, how did you do all of this? Well, because I know 3.2, 3.3, 3.4. I know them. I don't need to do this. I actually did something else that we're going to learn later. But the idea is that there is a more efficient way to do these things. Now, what is this over here? What does this do? That's a better question. What does this do? Don't give me the name of it. What does this do? It figures out the slope of the specific point. What do you want? Same thing? Anyone else? Rate of change. Yes. So this thing over here generates the numbers which are slopes of those tangent lines. Think of it as a generator. You plug in 1, it spits out negative 3. You plug in 10, right? It spits out negative 39. Those numbers, negative 39 and whatever else I had, those numbers are slopes of the tangent line. These particular functions which generate those slopes are called the derivative. That's the big point here. So, what is the derivative of a function? Derivative of a function is a function which generates slope of the tangent line. That's it. So the derivative is a function which generates or computes, whatever, computes slopes of the tangent line. So our formula that had XA, that one was specific because we were able to compute only one slope at a time because that XA was replaced with a value. So the first example we did with x equals 3, you only computed that one slope. Now we swap that particular XA with general x for any x. And when you get the slope of the tangent line in terms of any x, that particular function is called the derivative. So we are going to say that f prime of x is equal to the limit h goes to 0 of f of x plus h minus f of x over h. And this is the derivative formula, which is actually the slope of the tangent line. I'll put on a cloud. This computes slopes. So we're not learning derivative for the sake of the derivative. No one cares about the derivative. You care about slopes that it calculates, because those slopes measure the rate of change. So guys, this is so important for everything we do past 1800s, right? In terms of technology, when you drive and you look at your speedometer and you see, I don't know, 53 miles per hour, that is the slope of the tangent line computed from the derivative at the point. What point? The point in time, the instant in time when you looked at it. You all know that feeling when you are zooming on the highway, you see a cop, and you instantaneously look up at your speed, and you might say something. So that instant when you looked, that number, the first number that you seen, whether it's 43, whether it's 103, whatever it is, that value of the speed is the value of the slope of the tangent line. That is the velocity. It shows the rate of change because you are covering, let's not go with 103, let's go with 73. So you're covering 73 miles in 1 hour. That's what it means. So it's changing your position. It's telling you that if you allow time to go for an hour, you will go 73 miles. That's what it means, 73 miles per 1 hour. 106 miles, sorry, 146 miles for 2 hours, and so on. So the derivative formula is the one that gives you, so the derivative function, in our case, last case, we did negative 4x plus 1. That's the derivative, and you are allowed to take any x value. What does it mean, x value? Input value. In the case of my velocity example, you're driving, it's time. So you plug in, 3 p.m., 4 p.m., whatever you saw, or whatever. So the input can be time, the output could be velocity, but technically every other endeavor we do is measured this way. As I said, you are the tallest when you wake up in the morning, and you are the lightest when you wake up in the morning. Before the bed, you should be the heaviest and shortest for that day. So, I'm sorry? Fractions of the inch, because the body weight compresses your joints. You get compressed when you lie horizontal. That's why we're not thinking standing up. Yeah. Because you extend. That's where most of the growth happens, right? The gravity is pulling you down all the time.
Then your muscles like...
Yeah, muscles will atrophy, and you will never get to play the basketball being 8.3 feet tall.
I'll be working out on the ground.
Oh yeah, the whole food thing. It sounds like one of those tubes go right through
Should I ask them if they would go for a guy who's 8 feet tall and just lay down and I don't think they would. You gotta actually move around and do stuff.
For now.
What if I make millions of dollars?
Laying down.
I'm just gonna say that you don't want those girls. All right. What was the making work?
I think NASA did a study like that, where they had people like lie down for like a month, right? Like gave them a computer and just like fed them and stuff, and all their muscles like.
For the trip to Mars, and then what they had people lie down like in the same like enclosed space for a set period of time.
Yeah, usually people are in space station for like 6 months at most, and so on, because of the weight and so on. But I mean, I will apply the rule more than time, just that. So long. More technology is pathetic.
Can't you won't come back either.
I mean,
Yeah,
what else are you really looking for?
that's true. Let's just talk about depressing things now. This class turned to. Okay, so philosophy 101. Just kidding. All right, so we have the notion of the derivative, and finally we understand what derivative is. So derivative is a function. I kind of get annoyed when someone says, what is the derivative, and they give me the formula in terms of the limit. No, that's how you find the derivative. So the formula that is in the cloud, that formula is for you to find the derivative. Understanding what derivative is a different thing. Derivative is going to be that function that generates all slopes so that you are not annoyed to do this procedure over and over and over again for any possible number that might be important for whatever reason. So separate those two concepts and yeah. So now what can we do? We can find slopes one by one. We can find slopes at once by just plugging x there, figure out the formula that will generate them all, and have that. So let's do one more example, say square root of x, because I know how much you love square roots. So find the derivative for f of x equals root x using the cloud formula. Observe that I don't care about the particular value of the slope, because when you find the derivative of root x, you will find them all. No matter what number pops up, other than negative values, right? You will be calculating.
That's what I do. Because I actually like when it's already like the 3x plus 8h
Okay, so you can't. Okay, great. Okay, so you can do it. Okay, fine. And then you need to, because what it does, and then hopefully it has the same search capability. Because what you can do is you can record the entire thing. Awesome.
No. I mean, there must be a mistake.
Okay, let's take a look at this and then go for a break and then do the review and then do the calculus for the rest of the day. Pretty much, yeah. So we're going to start with figuring out all of the pieces. I have that f of x is root x, and I also need to get f of x plus h, which, dare I say clearly, is root of x plus h, like this. So now, the derivative, which is f prime of x, is going to be limit as h goes to 0. I have a square root of x plus h minus square root of x over h. I have 0 in the denominator, which means that I have to do some witchcraft here, and that would be rationalizing. So I'm going to multiply numerator and denominator by root of x plus h plus root x. And that is going to solve this. So let's go. In the numerator, I have difference quotient. Sorry, I have a difference of squares. So I have x plus h minus x. And the cross terms cancel, right? When I multiply this one times this one, and when I multiply this one times this one, they have opposite signs and they just cancel out. So I skip that step. But if you go and you FOIL, you will get 4 terms and 2 will cancel. So these are the only ones that survive. On the bottom, I'm not going to multiply it through. I'm just going to leave it like this. That's what I said. Please pay attention. H. Thank you. So now, in the numerator, we see that x minus x cancels. And we are left with the limit h goes to 0 of h over h square root of x plus h plus root x. In which case, these drop, and we are left with the limit h goes to 0 of 1 over square root of x plus h plus root x. Now, when h goes to 0, you have a square root of x plus square root of x in denominator, which is apple plus apple is 2 apples. So we claim that if f of x is root x, f prime of x, then prime of x, let me just write then, f prime of x is 1 over 2 root x. That is the derivative. So now if you ask me what is the slope at 7, it's 1 over 2 root 7. Well, it's 2 root 7 over 14. What is the slope at 9? 1/6, and so on. Easy to compute. Also observe that function has the vertical asymptote at 0. The derivative also explodes at 0, right? You see that? So x equals 0 doesn't, for x equal to 0, what's happening for x equal to 0? I was thinking of 1 over x. For x equal to 0 is a point where the function begins. So you see that it has infinite slope. Look. Let me just try to do a better job. So anywhere you draw a slope, see that? These lines start, these lines from here, slope, 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 it goes like this, goes like this, goes like this. When it hits zero, it's going to be completely vertical. Slope is infinite. Why? Well, 1 over 0, infinity. See how awesome that is? Just from the right, nothing from the left. It can't be undefined. It's positive infinity. So the slope is, I don't know, at one point over here, slope is going to be 1, and then 2, 3, 4, 5, 6, 7, 8, 9, infinity. Right, as it goes there. So it's, you can see it from these concepts. You can also find when the function, when the derivative doesn't exist, when the derivative and so on. And we'll see, you know, as we talk about it in this next lecture, the connection between the function and the derivative. Now, why is this included on your first exam? It's included because if I'm just to show this much of a screen and kind of cover this so you can't see it, all you see is a 2.3 homework problem. This is the reason why this section is included on your exam next Saturday. We did not learn anything. I am not going to ask the definition of the derivative on the exam. That will be featured on the next exam, Chapter 3 exam, where you have to state what definition, what derivative means, not just how it's calculated. You are going to see questions, compute so and so. Now, I understand that you will know it's a derivative, but it's a 2.3 calculation. We use, and if you go to homework in 2.3, you will find these problems without them mentioning its derivative. So that concludes this. We are going to do a review after the break and these short commercials.
Yeah.